I would like to welcome everyone to the NPTEL course on the structural dynamics, theory and computation. So myself, Dr. Arnab Banerjee, Associate Professor at Civil Engineering Department of IIT Delhi, and the TAs of the course, so Rishabh Das, Arindam Das, Indrajit Pahari and Mayuresh Salonke. And we would and in this course of the structural dynamics, so you have mostly, so maybe you are doing the course from the background of civil engineering, maybe mechanical engineering or applied mechanics or aerospace engineering. So in this case, mostly you have seen or you have come across that structures are subjected to static loads, so which you have maybe done in your structural analysis courses. But here we will primarily focus how a structure behaves under the action of the dynamic loads. For example, if you have an earthquake, wind, then blast, some type of, or maybe some type of transient vibrations or steady state vibrations. So how the structures going to respond in those type of excitations, that will be our primary focus. And we will also try to see how the energy within the structure is get dissipated in this course. So primarily, these applications are encompassing in that civil engineering, ensuring the stability and comfort of the structure subjected to dynamic loads such as wind, traffic and human activity. In seismic engineering, that is designing of building, bridges and other infrastructure to withstand the earthquakes. Then aerospace engineering, analyzing the vibration and dynamic loads of the aircraft and spacecraft. And mechanical engineering, the studying the dynamic behavior of machinery and vehicles to ensure the safety and performance. And also sometime in case of the acoustics, we are again also able to implement this theory. But in this course, we will mostly discuss on the theoretical aspect of it, and we will see how we can proceed for the computation from this. So if you see the course content, that course content is primarily divided into the 4 main topic, that is HDOF system, numerical methods, multiple degree of freedom system and continuous systems. So in the single degree freedom system, we will mostly focusing we will spend mostly the first 2 weeks, module 1 to module 4. So there we will consider mostly the introduction to the dynamic system, single degree freedom system, undamped system. Then we will go to the damped system. Then we will see the energy and the phase portrait. Then we will introduce the force vibration undamped and force vibration damped. Then how the dynamic amplification can be calculated, how we can able to consider the phase angles, different type of forcing functions, energy method, and we will also show some solved example using MATLAB. On the other hand, if you see for the numerical methods, that will span from the 3rd to 5th week in the from module 5 to module 11. So there we will see how the D operator can be used. So we will provide some introduction to the Duhamel integrations, Euler integration, Newmark beta, explicit method, implicit method, basics of the ordinary differential equation solver, state space formulation, Runge-Kutta method, Fourier transformation, and examples solved using the MATLAB. So these are the primary content for the numerical methods. Then in case of the multi-degree freedom system, that will be from 6 to 9 week, and there it will containing from module 12 to module 18, and there we will first introduce the multiple degree freedom system. We will go deep into the eigenvalue solution, estimation of the natural frequency, modal analysis, response spectrum, and we will also discuss some provisions for the seismic analysis, vibration absorber, base excited motion, some optimization technique as well as, and also we will see some different types of the damping models such as Rayleigh damping, stiffness proportional damping, mass proportional damping, and finally we will also solve it using the MATLAB programs, and so that it will be much more visualizingly effective. And in the last one, we will do continuous system. So that will be spent from 10th to 12th week and module 19 to module 27. So here where so in the previous all those things were mostly the discrete, but now we are having a continuous system. So in this case, we are no longer solving the ordinary differential equation, rather we will solve the partial differential equations, and we will check for the bar, Euler-Bernoulli beam, Timoshenko beam, their natural frequencies, mode shapes, for the different boundary conditions, how they are acting, and the different cases like beam with tip mass. Then we will also see the Galerkin's approach and the Rayleigh-Ritchey method, and we will also estimate the damping of the continuous system, and finally we will also solve some example problem using the MATLAB. So with this, I would like to thanks to all of you and welcome you to the course of the structural dynamics, theory and computation. Thank you.